Welcome to Lesson 144, Directions in the Coordinate Plane. Today we're going to talk about how to determine the direction a point moved in the coordinate plane, and we're going to use directions to move a point in the coordinate plane. Right, so when we move something in the coordinate plane, it's what we call a translation. So you're going to get a little introduction here to a translation, but for the most part, we're just going to talk about directions on the coordinate plane, kind of like we're using a map and figuring out how many blocks or miles we need to move. So with translations, all you're doing is telling me how the point moved, and you have to think it can only stay on these lines, so it's kind of like line tag. So how did the original point, in this case we're going to call this the original point, so we'll call this point P. How did the original point get to the second point? And then this would be point P, the prime notation on it. The prime notation indicates that it is the second one. So in this case, I know that I had to move it up 1. So that's the first part, up 1. And then I had to move it to the right, and I can move it and count 1, 2, 3, 4, 5, 6, 7 times to get where it was. So up 1, right 7. Now we can also talk about this in terms of the cardinal directions, so north and south for up and down, and then east and west for left and right. So in that case, if we were talking about that, it would be north 1, east 7. So when we're moving a shape, or we're translating a shape in the coordinate plane, we have to make sure that we translate each separate point. So in this case, I'm going from a y of a -2 to a y of 6. So we have to make sure we're looking at the correct coordinate here. So I know that this is 6 and this is -2, so that's going to be a total of 8. So you can ignore the signs and say, all right, I'm at 6 plus 2 because I'm down on the other side. Okay, that's 8. However, if it's easier just to count and ignore all the steps, you can do that as well. So if I look at this point, I went up 2, 3, 4, 5, 6, 7, 8. So again, up 8, and then to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. Right 9. And you can check this again by looking at your coordinates and comparing the correct coordinate to the other one. So in this case, I have a -2 to a +6. So because I'm going negative to positive, I'm just going to look at the two numbers and add them. So I have a -2 to a +6, that's 8. And then I have a -7 to a +2. So again, it's going to take me 7 to get back to the y-axis, and then I'm going another 2 to the right, so that is 9. Again, this is all just introductory. However, when you move one point, now we need to check and make sure it's the same here. So it should be up 8, right 9. So 1, 2, 3, 4, 5, 6, 7, 8. So far, so good. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, and that should be the case for all of the points when you move them. All right, so what we're going to do is we're going to follow the directions, and we're going to translate the figure by moving 8 to the right and then 6 up. So if I take this, and I'm actually going to copy it so I can see where I started from. So I'm going to translate 8 to the right, 1, 2, 3, 4, 5, 6, 7, 8, and then up 6, 1, 2, 3, 4, 5, 6. It's as easy as that. Just follow the directions and then move the point to its new spot. All right, so I want you to try, and I want you to translate the figure by moving 4 east and 3 north. Now remember, you have several different points here. You have 1, 2, 3, 4, 5, and 6. All right, so I want you to try moving these on your own, and when you come back, we'll go over your answers. Alright, so when you did this, and I'm going to copy and paste just to make things a little bit easier here. I need to move east, which for left and right purposes is to the right, and I need to move 4. So 1, 2, 3, 4. And then I need to move north 3. 1, 2, 3. So you should have ended up with your hexagon right here. And your second hexagon should have stayed there. Right, now, another way that you can look at this is by translating each point as its own. So taking this and saying, okay, here's my first dot. It's at -2, -1. All right, so I need to move 4 east. So 1, 2, 3, 4. And then 3 north. 1, 2, 3. Now I need to move the second one, which is at -4, -2. So 1, 2, 3, 4 gets me back to the y-axis, which makes sense because of the fact that it's -4, -2 brings me back to the y-axis here. And then I need to go up 3. So 1, 2, 3 makes sense because at a -2, plus 2 would get me back to the origin or back to the x-axis, plus 1 would move me up 1. All right, same thing for my red dot. So since it's the same thing as on the same line as the pink dot, we can know that it goes right here, and then it needs to go up 3. 1, 2, 3. And to check to make sure, it's 1, 2 spaces between. 1, 2, so far so good. And again, 1, 2, 3, 4. 1, 2, 3. Same line as the black, and it's 1, 2, 3, 4 spaces. 1, 2, 3, 4 spaces, so we're doing well. And then we move 1, 2, 3, 4. 1, 2, 3. And the last dot. 1, 2, 3, 4. Good thing. Still on the same line as the green. And 1, 2, 3. 2 spaces away. We did perfect. Now we just connect the dots. So this is how we translate shapes on the coordinate grid. Here we're going to talk about using a map and moving in directions on the map. So I'm going to do one example with you, and then you are going to finish the rest of these on your own. If each unit equals 1 kilometer, use the compass to give directions for getting from home to, the first one is library. So we start from home, and I know that to go to the library, I need to go up, which in this case is north. So I need to go north, not just 1, but 1 kilometer. And then I need to go left, which is west, 2 kilometers. So north 1 kilometer and west 2 kilometers. So all in all, I'm going to walk 3 kilometers. What I want you to do is I want you to try these last 2 on your own and answer this last question. If you have any questions, be sure to post them to Edmodo so we can go over them in class.